Brandon Lewis here from Embedded Computing Design, and we're at Embedded World 2020, and I'm at the Code Sonar booth with Mark Hermeling. How you doing, Mark?
Wonderful. Day number 2.
Yes, day number 2. So you provide tools for testing, analysis, code analysis, but a lot of them are static analysis-based tools.
Yes.
Why do we need static analysis? Why can't we just have dynamic analysis and be done with it?
You'd think, right? So static analysis test tool, static analysis test tool tests code before you actually run it.
Right.
So you can actually test code really closely to where the developer authors the code. Mm-hmm. And a dynamic testing tool tests for the correctness of the code. So, for example, if you have a function plus, you add 1 and 2, you expect 3.
Right.
That's what the dynamic tool tests. But the static analysis tool can tell you whether in that arithmetic for that plus, you may have a null pointer dereference, a buffer overflow. These type of quality issues or security issues that you can fall over. And if you find them during the dynamic testing, you could be days or weeks after the actual author has written it, right? So doing static analysis is really cost affordable to get better code into your repository.
And then we all know that the later in the cycle that you find bugs, the more expensive, the more time consuming it is to fix them.
Yeah, exactly. We work with a lot of customers that realize that they should do static analysis. They do it at one point in the development cycle, which is wonderful, but as we bring that closer to the developer, it's more cost effective, so they get more value, more ROI out of their investment.
Very good. And you know, we're at Embedded World, you have C, C++, C#, these are the languages of this show, but increasingly developers today aren't using those languages. They're using Java, they're using Python, they're using all these higher level scripting types of languages. Can static analysis be valuable in that context as well?
Yeah, absolutely. So one of the things that we do is we support our customers from embedded to enterprise. Mm-hmm. So yes, absolutely, firmware, operating systems, middleware, applications at the edge is typically C, C++. Those are very dangerous languages, but Java, C#, Python, Node.js are all dangerous languages as well in their own regard. And there's checkers for that, and one of the things that Code Sonar does, our tool, is it actually integrates with open standards. So there's a standard called Serif, and we import and export Serif. So we're really friendly in working with other tools in the ecosystem.
That's very good. So what can you tell me about Serif? What is it, and then why is it important?
It is a static analysis results interchange format.
Okay.
So the whole idea is there's many different tools in a DevOps, continuous integration, continuous deployment cycle, right? Not just static analysis, there's dynamic testing tools. Right. There's editors, there's source control tools. And if you have to build an integration between every static analysis tool and every IDE and every dynamic testing tool, that gets really, really laborious and complicated.
Right.
So that's why a couple of different companies, Microsoft, Micro Focus, GrammaTech, and a few others, sat together and came up with Serif as an open standard to exchange data between these tools.
That's fantastic. If people are interested in learning more about static analysis, you can come to Hall 4 of the Embedded World and look for the GrammaTech booth, or go online to, what's the website?
GrammaTech.com.
Perfect. Well, thanks so much, Mark. I appreciate it.
Thanks, Brandon.